Imagine standing at the edge of everything, not the edge of a galaxy, not the edge of the observable universe, but the edge of time itself. Now ask yourself one impossible question. What happened before the Big Bang? At first, it sounds like a simple question, but it may be the single hardest question humanity has ever asked, because the deeper scientists investigate the origin of reality, the stranger the universe becomes. For more than a century, we've believed that our universe began with the Big Bang. It's often described as the moment everything exploded into existence. Movies show a giant explosion in empty darkness, sending stars and galaxies flying outward. But almost every part of that picture is wrong. The Big Bang wasn't an explosion inside space. According to modern cosmology, it was the rapid expansion of space itself. There is no known center of the expansion, and every region of space expands relative to others. That means there wasn't a giant fireball blasting into an empty universe. Space itself was changing everywhere. Think about drawing tiny dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. None of those dots is the center. From the perspective of every galaxy, it looks like everything else is moving away. That's surprisingly similar to what astronomers observe today. The farther away a galaxy is, the faster it appears to recede. This relationship helped establish that our universe has been expanding for billions of years. Now imagine reversing that expansion. Run the entire universe backward. Galaxies move closer together, clusters merge, stars disappear, atoms break apart, matter becomes unimaginably hot and unimaginably dense. Eventually, every observable part of our universe reaches an incredibly tiny, energetic state. This is the beginning of the story told by the standard Big Bang model. But here's where things become truly mysterious. When scientists try to calculate what happened at the very first instant, their equations stop working. Gravity, quantum physics, space, time. The mathematical framework we use to describe reality breaks down under those extreme conditions. It's as if the universe is hiding its own birth behind a curtain we can't yet see through. And that's where the real mystery begins. People often ask, what existed before the Big Bang? But some physicists believe that question may not even make sense. Why? Because according to our current understanding, time itself may have begun with the Big Bang. Imagine asking, what's north of the North Pole? There isn't another direction beyond north. The question itself stops making sense. Some cosmologists argue the same thing about time. If time began with the Big Bang, there may have been no ordinary before. Not because something is being hidden, but because before may simply not exist in the way we intuitively imagine it. But science rarely settles for simple answers because not every physicist agrees. Some believe the Big Bang was not the true beginning. Some think another universe may have existed first. Others propose that our universe emerged from a previous contracting cosmos. And a few theories suggest reality could be part of an endless cosmic cycle. These ideas remain hypotheses, not established facts, but they are actively explored because current physics cannot yet fully describe the universe's earliest moments. So, if the Big Bang wasn't the beginning of everything, what came before it? And could we ever prove it? That's where our journey really begins, because the next theory doesn't start with an explosion. It starts with another universe. When most people hear the words Big Bang, they imagine the absolute beginning, the moment reality suddenly appeared from nothing. But what if the Big Bang wasn't the beginning at all? What if it was simply the latest chapter in a much older story. Today, some physicists are exploring exactly that possibility, not because they've proven it, but because our current theories leave unanswered questions about the universe's earliest moments. One of the most fascinating ideas is called the Big Bounce. Imagine throwing a rubber ball toward the ground. It falls, hits the floor, and bounces back. Now imagine replacing that ball with an entire universe. According to the Big Bounce hypothesis, our universe may once have been a completely different universe. Instead of expanding forever, it began shrinking. Galaxies moved closer together, stars disappeared, matter became hotter, denser, and more compressed than anything we can imagine. Eventually, everything collapsed into an unimaginably dense state. But instead of ending there, it bounced, and that bounce became what we now call the Big Bang. If this sounds unbelievable, you're not alone. For decades, many scientists thought such an event would be impossible. General relativity predicts that an infinitely dense singularity forms under these conditions, a point where the equations themselves stop working. But here's the problem. When gravity becomes incredibly strong, another set of laws begins to matter. The strange world of quantum physics. And this is exactly where modern cosmology reaches one of its biggest gaps. We have an incredibly successful theory of gravity. We also have an incredibly successful theory of quantum mechanics. But no confirmed theory successfully combines both under the extreme conditions of the universe's birth. That's why physicists continue searching for something called quantum gravity. If such a theory is correct, space itself might behave very differently at unimaginably small scales. Instead of collapsing into an impossible singularity, the universe might reach a minimum size before expanding again, like a cosmic heartbeat. Expand, contract, bounce, again and again. This remains speculative, but it is one of several serious ideas being investigated because current physics cannot fully describe the earliest instant of the universe. But the Big Bounce isn't the only possibility. Another idea is even stranger. What if our universe isn't the only one? Some inflationary cosmology models suggest that new universes could continuously form, leading to a much larger multiverse. These ideas are actively researched, but have not been confirmed by observation. Imagine bubbles forming inside boiling water. Each bubble is its own universe, each with its own space, its own time, perhaps even its own laws of physics. If that's true, our Big Bang may have been nothing more than the birth of one bubble inside a much larger cosmic reality. But here's the difficult part. How do you test any of this? You can't travel outside the universe, you can't observe another universe directly, and you certainly can't rewind time to watch the first fraction of a second. Science depends on evidence. Without evidence, even the most beautiful idea remains only a hypothesis. That's why cosmologists continue searching for clues hidden in the oldest light in the universe, the cosmic microwave background, or in future observations such as primordial gravitational waves that could reveal what happened in the earliest moments after the Big Bang. So where does that leave us? Maybe there really was a universe before ours. Maybe the Big Bang was a bounce. Maybe countless universes exist beyond anything we can observe. Or maybe we're asking the wrong question entirely, because there's one idea that changes everything, an idea suggesting that there was never a before to begin with. And if that's true, it completely changes what we mean by the beginning of reality. Imagine that one day humanity finally discovers a complete theory of the universe, a single equation capable of explaining gravity, quantum physics, space, time, and the Big Bang itself. Would that finally answer the question? What happened before the Big Bang? Maybe, but maybe not. Because the deeper science explores reality, the more we discover that nature doesn't always answer the questions we expect. For decades, astronomers have been searching the universe for clues about its earliest moments, not by looking farther into space, but by looking farther back in time. Because light takes time to travel. When we observe a galaxy 10 billion light years away, we're seeing it as it existed 10 billion years ago. Every powerful telescope is also a time machine. And the oldest light we've ever detected is something called the cosmic microwave background. It's a faint glow that fills the entire universe. Not visible to our eyes, but detectable with sensitive instruments. This ancient radiation was released about 380,000 years after the Big Bang, making it one of the oldest direct pieces of evidence we can observe today. Scientists study this ancient light with incredible precision. Tiny temperature variations, smaller than 1,000th of a degree, reveal how the first structures of the universe began to form. Galaxies, stars, planets, eventually us. But here's the problem. The cosmic microwave background doesn't show us the exact beginning. It only shows us the universe, after it had already cooled enough for light to travel freely. Everything before that remains hidden behind an observational wall. It's like arriving at the scene of a mystery, hundreds of thousands of years after it happened. You can study the clues, but not witness the event itself. So, how do scientists hope to look even farther back? One possibility is primordial gravitational waves. Unlike light, gravitational waves could carry information from much earlier in cosmic history. If detected with the right properties, they could reveal how the universe behaved during its earliest fractions of a second, and perhaps even distinguish between competing models of the early universe. Another possibility is that we'll finally develop a successful theory of quantum gravity. Today, our two greatest theories describe reality almost perfectly. Einstein's general relativity explains planets, stars, black holes, and galaxies. Quantum mechanics explains atoms, particles, and the microscopic world. Both have passed countless experiments, yet when we try to describe the universe at the very first instant, they become incompatible. It's as if reality is speaking two different languages, and humanity has not yet learned how to translate between them. Maybe. The answer is a big bounce, maybe. Our universe emerged from a previous universe. Maybe time itself has no true beginning. Or maybe the concept of before simply doesn't apply. Right now, no one knows. And that's one of the most beautiful things about science. Science isn't a collection of perfect answers. It's a method of asking better questions. Every discovery solves one mystery, while revealing 10 more. Thousands of years ago, people looked at the stars and wondered what they were. Today, we know they're distant suns. A century ago, we didn't know the universe was expanding. Today, we can measure that expansion. Perhaps 100 years from now, someone will watch this very question and smile, because by then, humanity may finally know what came before the Big Bang, or perhaps we'll discover that there never was a before at all. Until that day, the greatest mystery in the universe remains unsolved. Not because science has failed, but because we're still exploring. Every telescope we build, every equation we solve, and every question we dare to ask brings us one step closer. Maybe the answer is waiting, hidden somewhere, in the oldest light, the faintest gravitational wave, or inside a theory no one has discovered yet. So let me leave you with one final question. If the universe had a beginning, what created the conditions for that beginning? And if it didn't, has reality always existed? Whatever the answer is, it may completely change everything we think we know about time, space, and our place in the cosmos. Because sometimes the greatest discovery isn't finding the answer, it's realizing how extraordinary the question truly is.